Welcome to episode 2 of Play, Neuroscience, Motivation, and Pedagogy. In this episode, we will explain the neuroscientific benefits of play. Learning takes place when an individual is actively engaged in the learning process. When learning occurs, there are changes in the neuronal connections in the brain. Passive learning experiences, however, do not cause changes in the brain's neuronal connections.
Learning is holistic, and it enhances the development of multiple domains. Learning refers to the ability of the brain to process and respond to multimodal or sensory stimuli at both basic and complex levels in the brain. Sensory inputs include information coming from sight, hearing, taste, smell, and touch. Play supports a developing child's capacity to learn by activating interconnected brain networks.
There are 5 characteristics used to define playful learning: joyful, meaningful, actively engaging, iterative, and socially interactive.
When a child is involved in a joyful learning experience, there is an increase of dopamine levels in the brain's subcortical limbic system. Brain structures involved in joyful learning include the midbrain, striatum, hippocampus, and prefrontal cortex. Activation of the limbic system is linked to enhanced motivation, attention, memory, creativity, mental shifting, and stress regulation.
Meaningful play supports a child's ability to make connections between familiar and unfamiliar tasks. The child makes connections with existing mental frameworks and activates areas in the brain associated with analogical thinking, memory, metacognition, motivation, and reward.
A child who is actively engaged increases brain activation related to decision making, agency, and flow. Active engagement requires focus, attention, and the ability to respond to the stimuli in the environment. Research indicates that active engagement in play involves the inferior frontal gyrus as well as the left putamen. The involved brain networks are responsible for attention control, goal-directed behavior, reward, temporal awareness, long-term memory retrieval, and stress regulation. Playful activities that encourage active engagement increase memory, encoding, and retrieval processes to support learning.
Iterative play experiences are characterized by repetition of an activity to build on previous learning and to build new understanding. Iterative play involves experiment, imagination, and problem solving. The primary brain structures include the ventral striatum, the nucleus accumbens, and the lateral prefrontal cortex.
Children learn through their interactions with others. Learning is influenced through an individual's interaction with their environment and culture. Through play, which involves social and peer interactions, children build language and executive functioning skills.
Children involved in play-based programming demonstrate better executive functioning skills, including inhibitory control, working memory, cognitive flexibility, and social emotional development.